So now in this video we're discussing about the mobility of charge carrier. Mobility of charge carrier, that is what is charge carrier, electrons and holes. So in this video we're discussing about the mobility of charge carrier. Now what is the mobility? Mobility is how fast, that is defined as how fast an electron or holes, that is how fast an electron and hole is moved from one point to another point. So one point to another point, how an electrons or holes is moved is how fast. So the speed is known as the mobility. So write down this definition. Now what is the formula of mobility? That is mu equals to drift velocity by field intensity. So what is mobility? The formula is drift velocity by field intensity. What is drift velocity? We denoted at Vd, and field intensity denoted as E. So this is the formula of mobility, that is drift velocity by field intensity. Now what is the unit? How we calculate the unit? That is the drift velocity unit. What is that? Meter per second. And field intensity unit, we already know that volt per meter. So if we cancel out, not cancelling out anything, so meter square, that is meter per second into volt per meter. So meter per volt, that is what is coming out, that is meter square per whole second. This is the unit of mobility. This is very important concept. Now what is Vd? What is Vd? That is drift velocity. Now what is drift velocity actually was? What is drift velocity actually it is? So drift velocity is the velocity of charge carrier under field intensity. Velocity of charge carrier, that is velocity of charge carrier, that means electron or holes, under an electric field. Under an electric field, the velocity of charge carrier from one point to another, the speed, that is called drift velocity. What is the normal speed? That means charge carrier speed is known as drift velocity. That is, you write down the definition here, that is the velocity of charge carrier under field intensity. Under field intensity, the velocity of charge carrier. Or we can, another definition we get that is average velocity of the charge carrier. That is average velocity. Another definition is average velocity of charge carrier. So average velocity of charge carrier, that is electrons or holes, the average velocity of electrons and holes. Now what is the average velocity? So now we write down the equation of average velocity. So average velocity, AVG, average velocity, or we denote it as V average, or we note that this is the drift velocity. So drift velocity equals to V max, maximum velocity of an electrons or charge carrier, plus V min, that is minimum velocity of charge carrier, by 2. So as you know, this is the formula of average for getting the average. So here, if getting the velocity of average velocity, so V max plus V min by 2. So what is the unit of this? is meter per second. So now this you need to remember. Sometime question we get the question, for that we need to know about the formula of the drift velocity. So now in mobility section we need to know about the mobility value of germanium or silicon. So electron, obviously you know that for electron mobility we denoted as electron mobility as mu suffix n, or we denote it as mu suffix e for electron, and hole mobility for hole mobility we denoted as mu p or mu h. So this is the this is the symbolic representation of mobility, mu. So now denoted as mu mobility. So for a electron mobility, obviously n for negative charge and p for n for negative charge. You notice electron charge is negative, and p, that is hole, that is positive charge. So p why denoted positive charge for hole, and n for negative charge. So why this is known as, so p mu n and mu p. Electron negative, so n is negative. N for negative, and h hole. So hole is positively charged, so that why we denote it as mu p for positive. Now what are the value of germanium and silicon of the mobility? Germanium and the silicon, we make a table. Here that is mu n for electron mobility, mu n, and hole mobility mu p. So this is mu n, mu p, and for germanium the value of electron for mobility for germanium, the electron mobility or for electron or negative mobility is value of 3800 centimeters square per whole second. And for silicon, the electron mobility value is 1300 centimeters square whole second. Unit is same for hole mobility also, but the value is changing. Here that is 3800, and for hole mobility of germanium is that 1800. Value is 1800. Unit is same. And for silicon, the value of hole mobility is 500. Unit is same. So you need to remember these four value, that is mu n, mu p, and germanium for silicon 3800, and for silicon 1300, and for hole 1800, and for silicon 500 hole mobility. So you need to remember for this, for the mathematical problem. Sometimes it is given, sometimes it is not given in the question. So you need to remember these four values. Another thing you need to remember that the ratio of electron mobility and hole mobility. For germanium, the value is 3800 divided by 1800. The value becomes 2.1. And for silicon, the value becomes what is the silicon hole mobility? That is 1300 divided by 500. So the value becomes 2.6. So it is the ratio you need to be remember. Sometime in the question you need to remember the value for finding some electrons for mathematical problems or numericals. So that's why the ratio is, you need to remember, 2.1 for germanium and 2.6 for silicon. So now there are some points about the mobility. You need to remember the points and need to note it down on your notebook. That is, First point is electron mobility, that is mu n. I am writing in short manner, you write in details. That is electron mobility is always greater than, that is electron mobility is always greater than whole mobility. Always greater than whole mobility. So that is what is defined, that is the electron is move faster than holes. As compared to hole, electron is move faster. So electron mobility is faster or greater, electron mobility is greater than hole mobility. Therefore the electron can travel faster and also continue to larger current compared to holes, and contribute larger current compared to holes. This is the first point. The second point is the mobility of charge carrier always decrease with temperature. That is the mobility of charge carrier alwaysly decrease with increasing with the temperature. That is temperature. That is T minus whole to the power m. There is you need to be remembered, that is mu is always proportional to T to the power minus m. That is, if we increase the T, so mu will be decreases. When mu will be increases, T will be decreases. That is inversely proportional. So as we in real time example, now where m is a constant, so mu is inversely proportional to T to the minus m or proportional to T to the minus m, where m is a constant. What is the value of m? The value of m equals to, you need to remember, for 2.5 for electron and 2.7 for holes. This is for silicon. And for germanium, the value is 1.66 for electron and 2.33 for holes. This is for germanium. So you need to remember this value only for IES, this engineering services. No need to remember for GATE examination as your semester examination. This is important for the IES examination. You need to remember these values. So now here m is not m is not equals to 1 because m have some value. So mobility decreases as nonlinear variation with the temperature. So mobility decreases with the nonlinear variation with temperature. And so mobility of charge carrier. Now the third point is mobility of charge carrier depend on two parts. So one is temperature. What do you conclude that? That is mobility depend on me. One is temperature, and another one is impurity atom. Impurity atom. So the mobility of the charge carrier is a function of two. One is temperature and second one is impurity atoms. So now you can note down the note here. What is the note? That is mu decreasing with increasing of temperature. That is opposite. And another point is that mu is decreasing with obviously also increasing of impurity atom. If we increase the impurity atom, then mu, that is mobility, will decreases. Obviously there are more impurity atoms, so speed is also low, so that's why mobility is reduced. So here temperature, so as we know this is already, so these are the note. Now also another short note here, that here there is a two note, that is two graph is important, that is three graph are important for the mobility concept. Here this is the mobility is drawn in a y-axis, and in x-axis this is impurity atoms. So the electron mobility is graph is like that, and the whole mobility graph is like this, look like this, and T where temperature is kept constant. Now in the second graph, this is the mobility changing according to the when temperature is increases, and this is mobility, and this in x-axis we plotted in temperature in degree Kelvin unit, and impurity, here impurity atoms are kept constant, and the graph is become like this manner. As we know, mu is proportional to the temperature to the power minus m. So by this graph is look like this. And another graph is mu versus electric field. Let's discuss later. Now this is the graph of mobility. So this is the plot of electric field in x-axis and mobility in y-axis. The graph is look like in this structure, and first is linear, that is constant of mobility, no increasing. Now the mobility, the graph is become the relation between mobility and electric field is that mu is inversely proportional to the root of our electric field. In that position, in this line, mu is inversely proportional to the electric field. So first constant, then 1 by root, then 1 by electric field. So this is the graph of between mobility and electric field. This is very important concept. And the electric field, we know that this is the unit volt per meter. So now in the next video we're talking about the mass action law, or another some notes I have taken here. Here another some small note is here, that is electric field and Vd, that is the drift velocity. Now when the point is that in a semiconductor if electric field is gradually increasing, that is धीरे धीरे increase होता है, that is electric field is gradually increasing, the drift velocity, that is Vd, first क्या होता है, the drift velocity first linearly increasing, then after that sublinearly increasing, then after into saturation, then it becomes enter into saturation region. So first linearly increasing Vd, and then sublinearly increasing, then saturation, then enter into saturation region. So this is the relation of electric field and drift velocity, as we can talk in here, that is if we increase in gradually, then how type of the graph of the Vd is increasing. Here this is another important concept or note you can say here. Now in the next video we talking about the mass action law.